Hello, I am Kaini. Today I have selected another question from A-level past year paper. This is on complex numbers. The paper is actually, code of the paper is 9709. This is paper 3, therefore pure math 3, and then variant 2, May, June 2014. It is given that one of the roots of this cubic equation is -1 plus a square root of 5i. Then he is asking us to find the value of a and write the other root, other complex root of the equation. Okay. There are two different ways to do it. One way is that if we know this identity, a plus b to power of 3 is a cube plus 3a square b plus 3ab square plus b cube. If you don't know this identity, just multiply a plus b 3 times, you will get it. Therefore, it is not very complicated things. Therefore, this is a plus b to power of 3. Now, if this is one of the root, should satisfy this equation, means -1 plus square root of 5i to power of 3. Let us calculate this, then after that I will substitute here. Therefore, this will be -1 to power of 3, -1 to power of 3, plus 3 times of -1 to power of 2 times a square root of 5i, plus 3 times of a times a square root of 5i square plus square root of 5i to power of 3. Now, this is -1. This will be 1, this will be 3, therefore this is 3 square root of 5i. This is -1, I square also is -1, therefore this negative cancels this negative. 5 square, square root of 5 square is 5, 5 times this is 15, therefore this is 15. Now, this to power of 3 means 5 square root of 5, therefore this is 5 square root of 5. I to power of 3 means -i, therefore this is -i. Therefore, now here you can write this is 14, this and this will be -2 square root of 5. Therefore, this is z to power of 3. Now, if substitute here, what we are going to get? Therefore, 14 minus 2 square root of 5 plus 2 times of z plus 2 times of z is -1 plus square root of 5i plus a should be equal to 0. Just simplify this. This you are getting 14 minus 2 square root of 5 minus 2 plus 2 square root of 5i plus a should be 0. Therefore, this cancels this. This is 12. So a is equal to -12. Now we got the value of a. Now, second, in the same part A, he is asking us to write down other complex root of this equation. We know that if the coefficient of any equation, the coefficients are real numbers, same as 1, 2, and then 12, -12 here, all real numbers, the roots are in the conjugate form. If they have a complex root, that should have its conjugate also. That means the root comes in the conjugate form. Therefore, if one of the root is this, the other root will be conjugate of this. Therefore, if z is equal to -1 plus square root of 5i is one of the root, then z star, which is -1 minus square root of 5i, is the another root. Therefore, whenever all the coefficients are real number, the roots are in the conjugate form. That means if one of them is there, the other one should be there also. Therefore, this is the other root of this equation. Now, second part is not related to the first part. Therefore, I will erase this. Let us see what the second part is asking. He says that there is a complex number W where the modulus is 1 and the argument is 2 theta radian. Show that this is this much. Therefore, we know that W is equal to modulus is 1 and also argument is 2 theta. Therefore, W is equal to 1 times cos 2 theta plus I sine 2 theta. So, I will substitute it here. Therefore, we are supposed to solve W minus 1 divided by W plus 1. Therefore, here getting cos 2 theta plus I sine 2 theta minus 1, and here you are getting cos 2 theta plus I sine 2 theta plus 1. Okay, I will erase this part and then write some of the identities which I'm going to use. Now, look at here, we have tan theta. Therefore, we have to use all double angle formulas to change this to theta. Therefore, we know that cos 2 theta is equal to cos square theta minus sine square theta. Sine square theta. And we know that sine 2 theta is equal to 2 sine theta cos theta. And also we know that cos square theta plus sine square theta is equal to 1. Okay? Now, let's see what we are having here. So, this will change to cos square theta minus sine square theta plus 2I sine theta cos theta minus 1. And here we are getting cos square theta minus sine square theta plus 2I sine theta cos theta plus 1. Now, look at here, cos square minus 1 is actually minus sine square from here. This being that side, this being this side, cos square minus 1 is minus sine square. Therefore, these two changes to minus sine square. Therefore, this and this will be minus sine square. And there is another sine square here, therefore, we are getting minus 2 sine square theta plus 2I sine theta cos theta. Here, 1 minus sine square theta is cos square theta. Again from the last formula here, we can see that sine square is equal to 1 minus cos square. Therefore, or other way around, cos square is equal to 1 minus sine square. Therefore, these two changes to cos square. 1 cos square also here. Therefore, 2 cos square theta plus 2 I sine theta cos theta. Now, this negative, if I write this negative, I write as a I square, then I can factorize here. Therefore, this negative I will write as a I square. Therefore, you can see that 2 is common, I is common, sine is common also. Therefore, I can factorize 2 I sine theta. What will remain from here? I sine theta will remain from here. I sine theta will remain here. 2 is gone, therefore this will remain only cos theta. If I factorize here 2 cos theta, what I'm going to get? I'm going to get cos theta plus I sine theta. You can see that these two are exactly same. These two cancel these two, then sine over cos is tan. Therefore, I tan theta. Therefore, we got the answer. Therefore, this is equal to I tan theta. If you want me to solve any question for you, put them in the comment section below, and I can go through that, and then I will solve it for you and put it in our channel. Thank you for watching.